Hi, everybody, and welcome back to Appendix 6 Alpha in our first video. Here we're going to be analyzing mixed costs, which we briefly went into in Chapter 6. Here, mixed costs contain both a variable and a fixed cost element. So here's an example of a utility cost. Actually, a very nice one. Here we have a fixed monthly utility charge, and then we have variable costs on top of that depending on our usage. Okay, so now that we have our activity on the x-axis and our costs on the y-axis. So account analysis and an engineering approach are different. In an account analysis, each account is classified as either variable or fixed based on the analyst's knowledge of how the account behaves. An engineering approach classifies the costs based on an industrial engineer's evaluation of production methods and material, labor, and overhead requirements. So let's take a look at this. If we analyze a mixed cost using a scatter graph, or plot, and the high-low method. So let's see. Here we have hours of maintenance and the total maintenance costs. So we're going to assume the following hours of maintenance work and the total maintenance costs for 6 months. And here's the schedule that does that. Now, what we do is maybe we plot it. And here it is. So we can lay a ruler judgmentally on that and kind of try to draw a estimate of what we think that plot would look like, with the y-axis being the dependent variable and the x-axis being the independent variable. So you hearken back a little bit to your earlier mathematical training for that. Okay, so here is the total mixed cost line. It's expressed as follows. The total mixed cost, that's y, is equal to the total fixed cost plus the variable cost per unit of activity times the level of activity. And the graph would look like this. Okay, so now if your fixed monthly utility charge is $40, your variable cost is 3 cents per kilowatt hour, and your monthly activity is 2,000 kilowatt hours, what is the amount of your utility bill? And I think you can easily see it would be the $40 of fixed cost plus 3 cents times 2,000. And that comes out $100. Okay, so now if I use the high-low method, I'm going to select the high and the low values. Here we have a low value for February and the total costs associated with that. And here in June we have the high, which is not terribly untypical for electrical expenses. Those usually run higher in the summer months. So here then we have our high 850 worth 9,800 and our low 450 7,400. We calculate the change. I often call that the delta. So the delta is 400 hours difference and the maintenance cost is $2,400 difference. We divide that hours into the cost and we get $6 per hour of variable cost per hour. Now, if I plug this into the formula a little bit, our total fixed cost equal total cost minus variable cost, we know the total cost. It's $9,800. And we know if we run 850 hours, that's going to be multiplied by the $6 variable cost per hour. So if I take my fixed cost and I minus my variable cost here, my total fixed cost is going to be $4,700. So the $9,800 represents our total cost, the $4,700 represents the fixed cost, and the $5,100 represents our variable cost. So theoretically, that $4,700 should continue. Let's see. So now you can see that we would do it expressed as an equation. Here's our fixed cost plus our variable cost equals our total cost. All right, let's do a quick check. Sales salaries and commissions are $10,000 when 80,000 units are sold, and 14,000 when 120 units are sold. Using the high-low method, what is the variable portion of the sales salaries and commissions? Give you a second to think about that. Okay, what we're going to do here is we're going to take the $4,000 difference between 14,000 and 10,000 and divide that by the $40,000 difference between 120,000 units and 80,000 units. We'll divide that 4,000 by 40,000 units, and that's going to give me 10 cents per unit variable cost. Okay. So, same situation exactly here. What is the fixed portion of sales in this particular case? So we've already calculated that our total cost is $14,000 at the high. The total fixed cost is what we're solving for. And we'll multiply the 10 cents that we just calculated in the previous slide times the 120,000 units that were sold. And if we do that, we'll take the 14,000 total cost minus the 12,000 variable cost, and that leaves us with $2,000 of total fixed costs. Okay. So now if we analyze a mixed cost using a scatter graph plot and a least squares regression method, let's take a look at that. A method used to analyze mixed costs, if a scattergram plot reveals an approximate linear relationship between the x and y variables. And this method is going to use all the data points to estimate the fixed and variable cost components of a mixed cost. The goal here is of the method is to fit a straight line to the data that minimizes the sum of the squared errors. Now, we are doing regression analysis when we do that. So, least squares regression. And so, Excel can be used to estimate the intercept, that's the fixed cost, and the slope, that's the variable cost per unit, that minimize the sum of the squared errors. So the cost analysis objective is the same. Here are total cost, fixed cost, variable cost. Least squares regression also provides a statistic called R squared, which is a measure of the goodness of the fit of the regression line to those data points. So here, the regression line in the form of y equals alpha plus Bravo X-ray is fitted to the data, where A is the intercept representing the fixed cost, and B, Bravo, is the slope representing the variable cost per unit of activity. So in our maintenance cost example, the slope of B is $6.02, and it represents the estimated variable maintenance cost per hour of maintenance. The intercept A is $4,395.67, and it represents the estimated fixed monthly maintenance cost. We'll note here that R squared is approximately 0.92, which is a really good fit. 100% would be a perfect fit, but that's rarely the case in real world data. And that indicates that there's 92% of the variation in maintenance cost is explained by variation in maintenance hours. 92%, very nice. Okay, so two methods we just discussed provide different estimates of fixed and variable components of a mixed cost. This is expected because each method uses differing amounts of data points to provide those estimates. Least squares regression provides the most accurate estimate because it uses all the data points. All right, that is our one video on Chapter 6 Alpha. I think you'll find that very useful, and when we return, we'll take a look at Chapter 7. Until that time, bye for now.